Hello again and welcome to Astronomy Daily. I'm Steve, your host, and we've got supernovas and Artemis, and Hallie will be back with us again. Stay with us.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Yes, that's right. Another episode of Astronomy Daily. Thanks for joining us, and with us as usual, Hallie, how are you?
Hi, Steve. Great to be back.
So, what have we got on today, Hallie?
Well, I'm talking about a new YouTube video about Artemis that features a soundtrack by the metal band Metallica.
Yeah, why not rock a rocket?
Funny, and you are covering the launch of the Indian Space Research Organization's Chandrayaan-3 lunar mission.
Yeah. Did you hear how much it cost them?
No.
Oh, wait till you hear. I couldn't believe it. Space on a budget. And I think you're looking at how NASA will be examining volcanic terrain on the moon with new instruments. That's on board the Artemis mission. Anything else, Hallie?
Yes, aren't you doing something about sandwiches?
Oh, right. Sandwich planets, yes. And also there's a story about a record number of amateur astronomers joined in a SETI-run program to observe a close-up supernova. That sounds pretty exciting. So let's get it on the air, Hallie.
Okies, here we go. A new video from NASA features Metallica's song, Fuel, alongside epic footage of Artemis 1, the mission that debuted the agency's huge new moon rocket, the Space Launch System, SLS. Give me fuel. Give me fire, the award-winning metal band sings on top of their characteristic power chords. The YouTube video also shows Artemis 1's SLS flying high into the night sky, from different angles. Artemis 1 was a success, sending an uncrewed Orion capsule to lunar orbit and back. NASA is now gearing up for Artemis 2, which will send 4 people around the moon no earlier than November 2024. In April, NASA named the 4 astronauts who will be on board, the agency's Reid Wiseman, Victor Glover and Christina Koch, and the Canadian Space Agency's Jeremy Hansen. Rock on, Artemis! As part of NASA's regular cadence of robotic lunar missions through Artemis, the agency has selected a new scientific payload to establish the age and composition of hilly terrain created by volcanic activity on the near side of the moon. The DIMPLE instrument suite, short for Dating an Irregular Mare Patch with a Lunar Explorer, will investigate the Ina Irregular Mare Patch, discovered in 1971 by Apollo 15 orbital images. Learning more about this mound will address outstanding questions about the evolution of the moon, which in turn can provide clues to the history of the entire solar system. DIMPLE will help determine whether irregular mare patches formed from recent or ancient volcanic processes. The mission will make use of a CLPS-provided rover, a collection gripping instrument, and a spectrometer that can help determine the composition of the lunar material to analyze the age and composition of samples collected from the surface of Ina. DIMPLE will be able to collect and analyze anywhere from 3 to more than 25 samples to learn more about the timing of the volcanic activity that formed this feature. For example, if the volcanic activity turns out to be geologically recent, it implies that either the lunar mantle was warmer than previously thought, or that radioactive elements contributed to small-scale eruptions continuing later in lunar evolution than previously thought. Either scenario would help us better understand the geochemical state of the moon over time. If, on the other hand, the eruptions creating Ina turn out to be older, it would lead to re-evaluating the age and evolution of craters on the moon, which would have implications for understanding the history of Earth and other planets in the solar system. The closest cosmic explosion to Earth in the last 10 years became a record-breaker for the Search for Extraterrestrial Intelligence Institute. The supernova, designated SN02E21, was first spotted on May 19, 2023, by Japanese amateur astronomer Koichi Itagaki. Just an hour after this manifestation, amateur astronomers taking part in SETI and Unistellar's Cosmic Cataclysms program were on the case. A record number of observers, including citizen scientists in the form of amateur astronomers, came together to collect data from a supernova that took place in the Pinwheel Galaxy, a spiral galaxy located approximately 21 million light-years from Earth. With the data, scientists could better understand the behavior of this class of supernovas known as Type II, cosmic explosions that occur when massive stars run out of fuel for nuclear fusion, and can no longer protect themselves against gravitational collapse. The effort involved 123 dedicated amateur astronomers making 252 observations, with 115 telescopes following how light from the supernova changed over time, first seeing its escalating brightness and then tracking its gradual fading. This allowed the SETI scientists to build a profile for the supernova that astronomers call the light curve, a measurement of its brightness over time. And the story isn't over for SN2023X. The supernova is expected to remain visible until at least August 2023, and while this is the case, the amateur astronomers of the Cosmic Cataclysms program will continue to monitor its progress. And that's all the news from me. Over to you in the kitchen with your planet sandwiches.
Roger that, Control. We're listening to Astronomy Daily, the podcast.
Yes, thanks for staying with us. It's Astronomy Daily with Steve. It's good to see the Indian Space Research Organisation got Chandrayaan 3 up into space on Friday. That's great news, and they did it on a budget, and we'll hear about that in a sec. Fantastic news. All sorts of things going on. I hear that China is going to be launching their own array of strings of satellites as well, so not to be outdone, they've got their own plans as usual, so leave it to the Chinese. Okay, on with the show. Now, this is exciting. On Friday, India launched a rocket carrying an unmanned spacecraft to land on the moon. It's its second attempt to do so, as its cut-price space program seeks to reach new heights. The heavyweight LVM-3 M4 rocket lifted off from Sriharikota in the southern state of Andhra Pradesh, carrying the Chandrayaan 3 spacecraft as thousands of enthusiasts clapped and cheered. Chandrayaan 3 began its journey to the moon. Health of the spacecraft is normal, said the Indian Space Research Organisation on Twitter. The world's most populous nation has a comparatively low-budget aerospace program that is rapidly closing on the milestones set by global space powers. Only Russia, the United States and China have previously achieved a controlled landing on the lunar surface. India's last attempt to do so ended in failure 4 years ago when the ground control lost contact moments before landing. I think that was Chandrayaan 2, and they only got 1.3 kilometres above the surface, if memory serves. A new chapter in space, in India's space odyssey. Prime Minister Narendra Modi tweeted from France, where he was taking part in the Bastille Day parade, or watching it in Paris. It soars high, elevating the dreams and ambitions of every Indian. Rightly so. If the rest of the current mission goes according to plan, the Chandrayaan 3, which means mooncraft in Sanskrit, will safely touch down near the moon's little explored south pole between August 23 and 24. Developed by ISRO, Chandrayaan 3 includes a lander module named Vikram, which means valour in Sanskrit, and a rover named Pangyan, which means wisdom. The mission comes with a price tag of $74.6 million, far smaller than those of other countries, and testament to India's frugal space engineering. Sure doesn't sound like an awful lot of money, does it? Experts say India can keep costs low by copying and adapting existing space technology, and thanks to an abundance of highly skilled engineers who, here's the key, earn a fraction of their foreign counterparts' wages. The Chandrayaan 3 spacecraft will take much longer to reach the moon than the manned Apollo missions of the 60s and 70s, which arrived in a matter of days. The Indian rocket is much less powerful than the United States Saturn V, and instead the probe will orbit the Earth 5 or 6 times elliptically to gain speed before being sent on a month-long lunar trajectory. The rover has a mission life of 1 lunar day, or 14 Earth days. And if the landing is successful, it'll roll off Vikram and explore the nearby Lunar area, gathering images to be sent back to Earth for analysis. India's space program has grown considerably in size and momentum since it first sent a probe to orbit the Moon in 2008. In 2014, it became the first Asian nation to put a satellite into orbit around Mars, and 3 years later the ISRO launched 104 satellites in a single mission. The ISRO's Gaganyaan spacecraft program is slated to launch a 3-day manned mission into Earth's orbit by next year. India is also working to boost its 2% share of the global commercial space market by sending private payloads into orbit for a fraction of the cost of its competitors. Now, a recent study presented at the National Astronomy Meeting in 2023, NAM 2023, examines a newly discovered planetary formation theory that challenges previous notions on how planets actually formed in disks of gas surrounding young stars, also known as protoplanetary disks. Based on data from observations and models, the researchers determined that 2 large protoplanets, planets that are still forming and gathering dust from throughout the disk, also known as accretion, orbiting at an indeterminate distance from each other, can produce a smaller planet orbiting between them, which the researchers refer to as a sandwiched planet formation. They surmise that this is due to the 2 larger planets limiting the amount of dust that flows into the inner portions of the protoplanetary disk, since they both will continue to collect it. When this happens, any planet that forms between them will be smaller than the 2 planets, which is analogous to the filling inside a sandwich. Researchers say that what is really interesting is that there are examples that have been found from exoplanet observations that actually show this sandwiched planet architecture, where the middle planet is less massive than its neighbours. Further studies are required to better understand this new formation process, but it could lead to developing plausible clarifications for the existence of Mars and Uranus, which are both smaller planets orbiting between larger planets in our own solar system. In the case of Mars, the larger Earth orbits inward while the much larger Jupiter orbits outward. In the case of Uranus, the much larger Saturn orbits inward while the smaller sized Neptune orbits outward. While the radius of Uranus is greater than Neptune, the former's mass is smaller, and this is due to Neptune's density being approximately 30% greater than Uranus. The current state of our solar system consists of a mostly neat and organised assemblage of planets, moons, asteroids and comets. This includes the Sun at the centre, followed by the inner planets, the asteroid belt, outer planets, Kuiper belt and Oort cloud. But things were much different approximately 4.6 billion years ago. And that's all we have time for today. Thanks for joining us on Astronomy Daily. I'm Steve with a sore throat and a upset tummy. I hope that didn't get in the way of anything. I certainly didn't have planet sandwiches, Hallie, wherever you've gone to. She's run off. But anyway, I hope you'll join us next time. I'm glad to have your acquaintance. Please don't forget, you can always leave your messages on our Facebook page, which is Space Nuts podcast group. I know. And for all the past episodes, don't forget you can go to spacenuts.io. That'll catch all the episodes of Space Nuts with Andrew Dunkley and Professor Fred Watson, and all the episodes of Astronomy Daily with Tim Gibbs and Steve Dunkley. Thanks again for joining us. See you later, Hallie.
See you next time, everyone.
Back in time to say ta-ta. All right. Bye, everyone.
Astronomy Daily, the podcast, with your host, Steve Dunkley.